Today we're going to look at lesson 1.9 on the applications of proportions. Okay. So in the last lesson we looked at writing some proportions and doing cross multiplying to simplify. Today we're going to be looking at some actual applications to use these proportions to solve for missing side lengths, or maybe look at relationships between different figures to see how they relate. So similar figures is something that we'll talk about today. Similar figures have exactly the same shape but not necessarily the same size. These guys are going to be proportional. So corresponding sides of two figures are in the same relative position, and corresponding angles are in the same relative position. Two figures are similar if and only if the lengths of the corresponding sides are proportional and all pairs of corresponding angles have equal measures. So here in this example we have triangle ABC and DEF. Angle A, B, C are all the same as angles D, E, and F. They correspond, they're equivalent. And that means when we look at the side lengths, side AB, side DE are going to be proportional. BC, EF will be proportional. FD and CA will also be proportional. So when stating that two figures are similar, you use the symbol like this. It's kind of like a little squiggly. For the triangles above, you can write triangle ABC is similar to triangle DEF. Make sure your corresponding vertices are in the same order. It would be incorrect to write triangle ABC is similar to triangle EFD, because then that would be saying A and E are the same angle when they're not. Okay, it has to be in the same order. So here we're going to be able to use proportions to find missing lengths in similar figures. So we're going to start by looking at example 1. We're going to be finding missing measures in similar figures. Here we have two triangles. We have triangle RST, BCD, and they're similar. So that means R and B are the same angles, S and C are the same angles, and T and D are the same angles. Okay, when you solve these, it might be easy to color code them to help you see what angles are corresponding, and that means what sides are corresponding. So here we want to go find the value of X. So I'm going to start by writing the sides of my triangle. So we have RST, okay, that's going to be the top of my proportions, and then we have BCD. So here, R and S, B and C are going to be the same. So I'm going to write A, 8 for my RST over the corresponding side that's in BCD, which is BC, so X, 8 over X. And then I have RT, 5, which corresponds to BD. So that's going to be 12. So I have 8 over X equals 5 over 12. And now we're going to cross multiply and solve. So 12 times 8 will give me 96. And then X times 5 will give me 5X. Now I have a one-step equation, so I'm just going to divide both sides by 5. 5 divided by 5 will give us 1x. And then 96 divided by 5 will give us 19.2. So our answer here, the length of BC, this X, is going to be 19.2 feet. So 19.2 feet is that distance of BC, which is our X value. For B, we have different shapes this time. We're going to find the value of X. We know that F, G, H, J, K, L is similar to M, N, P, Q, R, S. So that means here F and M are the same. G, okay, I'm going to highlight this one because this is the side that we have. G and N are the same. H and P, so I know G and M are the same. H and P are the same. So that means G, H, and NP will be the same. And then J, so I'm going to box that out. J and Q are the same. J, Q. And then we know that K, and I'll do a squiggle under this one, K and R are the same. So K and R. So that's a lot going on. That's why it might be helpful to color code, or like how I was doing. I was using different shapes or different lines to represent what is similar. So first we have F, G, H, J, K, L shape, and then M, N, P, Q, R, S. So first we know sides G, H, which is 4. And then GH corresponds to NP, which is 6. So we have 4 over 6. Then we know that JK, which is 2. So J was with the square, squiggle for K. QR is X. So we have 2 over X. So we have 4 over 6 equals 2 over X. And now I'm going to cross multiply. X times 4 gives me 4x. 6 times 2 gives me 12. So I have 4x equals 12, and I'm going to divide both sides by 4. 4 divided by 4 is 1, so I'm left with x. 12 divided by 4 gives me 3. So x equals 3, so that means QR is going to be 3 centimeters. There's a check it out problem for you to try, so go ahead and pause the video and try this one on your own. So it says, find the value of x in the diagram if A, B, C, D is similar to W, X, Y, and Z. So we have A and W are similar, so A, W, B, and X, so B and X, C and Y are similar, C and Y. Okay, so those are the two sides that we're going to need. So I have figure A, B, C, D, and W, X, Y, Z. So AB is 5, and AB corresponds to WX, which is 7, so I have 5 over 7, equals BC, which is 2, and then XY corresponds to BC, so that is X. Now I'm going to cross multiply, so 5 times X gives me 5X, and then 7 times 2 gives me 14. 5X equals 14, and now I'm going to divide both sides by 5. 5 divided by 5 is 1, so I'm left with X, and then I have 14 divided by 5, and that gives me 2.8. So the value for X in the side XY is going to be 2.8 inches. Now we're going to look at example 2. Okay. We are going to solve a proportion involving similar triangles to find a length that is not easily measured. Okay, this method is called indirect measurement. If two objects form right angles with the ground, you can apply an indirect measurement using their shadows. So we're going to look at examples that use indirect measurement here. So a totem pole casts a shadow that is 45, so the shadow is 45 feet long. At the same time, a 6-foot tall man casts a shadow that is 3 feet long. Write and solve a proportion to find the height of the totem pole. So here we have a pole, we also have a man that we are going to be comparing. We're going to have their actual heights and then their shadows. So the first proportion is going to be, or ratio is going to be the height of the pole to the man. Shadows will be the pole to the man. So I like to set it up, kind of looks like it might be a table in a way, but just to make sure all my information is organized and everything matches, because we have the pole all in the top, man in the bottom. Height in the first ratio, shadows in the second. So, height for the pole. Do I know the height for the pole? No, I'm going to find that out because it says write and solve a proportion to find the height of the pole. So that's going to be X. Height of the man. A 6 foot tall man. So man is going to be 6. Shadows of the pole. The pole casts a shadow that is 45 feet long. So pole for pole shadow, 45. A 6 foot tall man casts a shadow that's 3 feet long. So the man's shadow is 3 feet. So we have these two ratios, X over 6 equals 45 over 3. And now we're going to cross multiply. So 3 times X gives me 3X, and then I have to do 6 times 45, and 6 times 45 gives me 270. And then from here, I'm going to divide both sides by 3. 3 divided by 3 is 1, so we're left with X. And then 270 divided by 3 will give me 90. So here the height of the totem pole is going to be 90 feet. There are 2 check it out problems for you to try. So go ahead and pause the video and try these 2 on your own. Resume when you're ready to check your answer. Alright, so for A, it says a forest ranger who is 150 centimeters tall cast a shadow 45 centimeters long. At the same time, a tree cast a shadow that's 195 centimeters long. Write and solve a proportion to find the height of the tree. So for A, we have a ranger and we have a tree. We're going to have their actual height and their shadow. So we know, first, a ranger is 150 centimeters tall. So ranger height, 150. Cast a shadow that's 45 centimeters. So the shadow of the ranger is 45. A nearby tree cast a shadow 195 centimeters. So tree, shadow, 195. I don't know the height of the tree. So now I have 150 over X equals 45 over 195. So from here, I'm going to cross multiply. So 195 times 150 gives me 29,250. And then X times 45, 45X. Then I'm going to divide both sides by 45. 29,250 divided by 45 will give us 650. Equals 45 divided by 45 is 1, so we're left with X. So X equals 650. So the height of the tree is 650 centimeters. Part B, we have a woman who is 5.5 feet tall, casts a shadow that is 3.5 feet long. At the same time, a building casts a shadow that's 28 feet long. Write and solve a proportion to find the height of the building. Okay, so here we have a woman and a building. We're going to have their actual height and their shadows to compare. The woman is 5.5, so woman height 5.5. Cast a shadow, that's 3.5, so the woman's shadow is 3.5. The building shadow is 28 feet. We don't know the height of the building, so that's going to be x. So we're going to set up our fractions. And now we're going to go ahead and cross multiply. So we have 28 times 5.5. 28 times 5.5 gives us 154. And then x times 3.5 is 3.5x. So 154 equals 3.5. And now we're going to divide both sides by 3.5. 154 divided by 3.5 is 44. 3.5 divided by 3.5 is 1, so we're left with x. So x equals 44. So our answer, the height of the building, is 44 feet. All right, looking at example 3. So here, if every dimension of a figure is multiplied by the same number, the result is a similar figure. This multiplier is called a scale factor. So if we're scaling something by 2, it means we're multiplying everything by 2. If we're scaling it by 1/2, that means we're multiplying by 1/2 or dividing by 2 to make it smaller. So in example A, it says every dimension of a 2 by 4 inch rectangle is multiplied by 1.5 to form a similar rectangle. How is the ratio of the perimeters related to the corresponding sides? How is the ratio of the area related to the ratio of the corresponding sides? So there's a lot going on here. So first, 2 by 4 inch rectangle multiplied by 1.5. So we're going to take 2 multiplied by 1.5. That gives us 3. 4 multiplied by 1.5, that gives us 6. Okay, so triangle A is 2, or not triangle, sorry, rectangle A is 2 by 4, that's what we started with. And then to get our new rectangle, we multiplied by 1.5. So 2 times 1.5 gave us the 3, 4 times 1.5 gave us 6. So rectangle A is 2 by 4, B is 3 by 6. So first, we're going to look at the ratio of the perimeters. Okay, so perimeter, you add up all the sides. So this is 4 and this is 2, 6 and 3. So the perimeter of A is 2 plus 4 plus 2 plus 4. So the perimeter of A is 12. So 4 plus 4 is 8. 2 plus 2 is 4. 8 plus 4 gives us 12. So 12 is the perimeter for A. For B, 6 plus 6 is 12. 3 plus 3 is 6. 12 plus 6 gives us 18. So, to compare, the sides are 4 to 6, 2 to 3. Okay, the perimeters we just got were 12. So this is, the top is always going to be rectangle A, bottom rectangle B. So perimeter 12 to 18, and that simplifies. You can divide top and bottom by 6. So that simplifies to 2 over 3. Okay, so far the first, how is the ratio of perimeters related to the corresponding sides? Well, the sides are 2 to 3, perimeters are 2 to 3. So the ratios there are the same. Now we're going to look at the area. Area, you do base times height. So 2 times 4, 8. 3 times 6, 18. So for rectangle A, we have 8. Rectangle B, we have 18. we can divide top and bottom here by 2 to simplify it, and we get 4 over 9. Now 4 over 9 is not the same as 2 over 3, but we can rewrite this using an exponent, because 2 times 2 gives you 4, 3 times 3 gives you 9. So you can rewrite this as 2 to the second over 3 to the second, or 2/3 raised to the second, or 2/3 squared. So here, the relationship between the sides and the area, the ratio of the areas is the square of the ratio of the corresponding sides. So the sides and the perimeter, the ratios are the same, but when you compare the sides and the area, the sides ratio is squared when we look at the area. Now we're going to look at part B. So here we have 2 cylinders. So it says every dimension of a cylinder with radius 4 centimeters and height 6 centimeters is multiplied by 1/2. So in cylinder A, we're taking it and we're multiplying it by 1/2. So the radius, 4 times 1/2 gives us 2. The height, 6 times 1/2 gives us 3. So 4 times 1/2 is 2, 6 times 1/2 is 3. So we have these 2 cylinders here. It says, how is the ratio of the volumes related to the corresponding dimensions? So, first, we already know the radius is 4 in A. Okay, so we're doing A over B. So the radius in A is 4. In B, it's 2. And I can divide top and bottom by 2. So we get 2 over 1, which equals 2. Height in A, 6. Height in B, 3. Divide top and bottom by 3. So we get 2 over 1, which equals 2. So right now we know the radii and the heights equal 2. So the radius and the heights are the same ratio. Now let's see what happens to the volume. For the volume of the cylinder, it's pi r squared h. So pi times the radius squared times h. So for cylinder A, we have pi, radius is 4, squared, times 6. 4 squared is 16. 16 times 6 gives us 96. So 96 pi. For cylinder B, we have pi, radius is 2, so 2 squared, times 3, which is the height. 2 squared is 4. 4 times 3 gives us 12. So our volume of cylinder B is 12 pi. So now we're going to do the ratios. So here we put cylinder A up top, so 96 pi over 12 pi. Pi divided by pi is 1. So we can simplify that. So we have 96 over 12, which can be simplified even more. So we're going to divide top and bottom by 12. 96 divided by 12 is 8. 12 divided by 12 is 1. So here 8 over 1 equals 8, which is not the same as our radii and height. Not the same ratio. Doesn't simplify to the same thing. So we need to look at 8 a little bit more. 8 happens to be 2 to the third power, because 2 times 2 times 2 gives us 8. Okay, so 2 times 2 times 2 is the 2 to the third power, which equals 8. So we can rewrite 8 as 2 to the third power. So what this means is the volume is the same ratio as the radii, but raised to the third power. So the ratio of the volumes is the cube of the ratio of the corresponding dimensions. There is a check it out problem for you to try. It says a rectangle has width 12 inches and length 3 inches. Every dimension of the rectangle is multiplied by 1/3 to form a similar rectangle. How is the ratio of the perimeters related to the ratio of the corresponding sides? So go ahead, pause the video, take a moment to answer this question on your own. So we have a width of 12 inches, length 3 inches, and we're multiplying by 1/3. So I'm going to kind of make a table. So width, length, and we're going to have rectangle A, rectangle B. And what we started with will be rectangle A. So our width was 12, length 3. And then to go from rectangle A to B, we multiply by 1/3. So 12 times 1/3 will give us 4. 3 times 1/3 gives us 1. Okay? So rectangle B is a width of 4 and a length of 1. Okay? So now from here we have to find the perimeter, because it says how is the ratio of the perimeters related to the ratio of the corresponding sides. So let's do perimeter. So perimeter of triangle A, you do 12 plus 12 plus 3 plus 3. 12 plus 12 is 24, plus 3, 27, plus 3 is 30. So our total perimeter for rectangle A is going to be 30. Rectangle B, we do 4 plus 4 plus 1 plus 1. 4 plus 4 is 8, plus 1, 9, plus 1, 10. Okay? So now we're going to look at the ratios. Okay? So ratio of perimeter So we're going to do rectangle A over rectangle B. So we have 30 over 10, and that will simplify to 3 over 1. You can divide top and bottom by 10 here. Okay? And now we also have to look at the ratio of the sides, the corresponding sides. So for rectangle, we're going to do A over B again. So rectangle A, our width was 12. B was 4. And then we have length 3 to 1. You can divide by 4, divide by 4. So here, our ratio of our perimeter and the ratio of the sides are equal. So our answer is the ratio of the perimeters is equal to the ratio of the corresponding sides. They both equal 3 over 1, so they are equivalent.